The next topic about set is relations on sets. So try to compare these sets. Okay, which sets are equal? So try to see. And which sets are equivalent but not equal? So how do we know that a set is equivalent? And when will we know that a set is equal? So two sets, A and B, so that's the name, are equal, which is written in A equals B, if they have exactly the same elements. Exactly the same elements. So two finite sets, A and B, are equivalent if they have the same number of elements. So take note, the same number of elements. So there's a difference between equal and equivalent. So we try to see if the following sets, pair of sets, is equal, equivalent, or neither. So we have 2 and 4. So we have they have exactly different elements, and one set has two elements, and the other set has 3 elements. So we can say that letter A is neither equal nor equivalent. So let's have letter B. So we have set M, we have red, blue, green, and N set N is green, blue, red. So as you can see, it has the set element red, it has the element blue, and it has the element green. So there are the two sets have 3 sets, and they have exactly the same elements. So we can say that the letter B is both equal at the same time equivalent. So it can be applied to both. Let's have letter C. Set O has 2 and 4, and set P has 3 and 8. They have exactly different elements, but both have 2 elements. So we can say that this is equal. So sets O and P are equal because they have 2 elements each. So one-to-one correspondence pairs the elements of 2 sets so that for each element of one set there is exactly one element of the other. So there is a pair. And the 2 sets have the same cardinality, meaning the same number of elements. So let's move on to another terminologies that's needed: universal sets, subsets, and Venn diagram. So we have these cards. Form the following sets using the number of cards. Numbers less than 5. So we can have 1, 2, 3, 4. Do we include 5? No, because it states less than. 5 is not less than itself. So that's set A. We have 1, 2, 3, and 4. Set B, we have even numbers less than 6. Is 6 included? No, because it states there less than. So even numbers can be divided by 2. So we have 2, 4. So there are only 2 elements. So for prime numbers, set C, prime numbers. So prime numbers, these are numbers whose factors are only 1 and itself. 1 is neither prime nor composite, so that is excluded. So we start with 2. 2 is a prime number. 3, 5, 7. So these are the only prime numbers from 1 to 10. Numbers from 1 to 4, of course, we know them. We just simply list them down. 1, 2, 3, and 4. So there are 4 elements. Next, universal set is denoted by the set U. Usually, in mathematics books, it's like that. Others would even put like that. But literally, it's just letter U from the first letter of the universal set. It contains all elements being considered in a given situation. So everything in a given situation. So if you're going to draw it, so we represent the universal set, we put it inside rectangular shape, while smaller sets we put them in circular figures, which it can be represented here by A, but you can have more than one set, one smaller set. So subset, set A is a subset of B, which is written in this manner. If and only if every element of A is an element of B. So all elements in A must also be an element of B. So A is part of B. That's subset. Proper subset, set A is a proper subset of B, written A, this is the symbol, if and only if every element of A is also an element of B, and B contains at least one element that is not in A. So in this case, there are elements, B has more elements. While in the previous one, it's possible that everything in A can be in B, and everything in B can be in A. But in this case, A is really part of B, and B has an extra element that is not found in A. That's proper subset. So we represent proper subset in this manner. So we have a smaller set, which is represented by B. So everything in B is found in A, but there are elements in A that are not found in B.